Thermohaline circulation is a really powerful way of moving heat around the planet, and it's implicated in a lot of climate change processes. Now, we saw in the previous diagram, number 8, I think it was, how ocean circulation in the top 100 meters is influenced by wind, friction on the ocean surface. But the ocean is much deeper than 100 meters, and that's where this sort of circulation comes in. And rather than being driven by wind, it's driven by density. And density is controlled by temperature and salinity. So if the water becomes cold, it gets denser because the volume for the unit mass is less because it contracts, just like a metal bar contracts in the cold. But we can also add salt, and adding salt increases the density. Now we can add salt by evaporation, but also by the creation of sea ice, because as you create sea ice, it excludes salt slightly, and therefore increases the salinity. Okay, so the salinity of an ocean water is also controlled by how much fresh water we put in, the water that from melting glaciers or rainfall that comes in. So there's this balance between evaporation, fresh water, water entering the ocean system, sea ice, and things like that. Now, in the North Atlantic, we have this incredible system where warm water, less dense water, comes up from the subtropics, the Gulf of Mexico, and so it's already quite saline because of all that evaporation, and it moves north, gets colder, it gets even more saline because of the sea ice coming in, and effectively it's so dense that it begins to sink, and we get about 1,300 kilometers cubed of water each winter sinking. Okay, and that sort of drives this salinity. So we get cold, dense water sinking, and then it goes back down the southern Atlantic to the South Atlantic. So we can call that the Atlantic conveyor, if you like. So here we are, we're coming up the Atlantic, we're coming into areas off Greenland and Iceland. It's getting very cold and dense, and it's beginning to sink and then flow back. It's then influenced by Antarctica, which receives more cold saline water, goes back up the Pacific and Indian Ocean floors to rise off Alaska and off India, and back it comes. So it's a circulation that is pan-global. It's completely global, in fact, and it transfers large amounts of heat from places in the North Atlantic. We get warm water flows, provides about 4 times the heat from the sun. It's worth about 12 to 15 degrees to the west, the eastern side of the Atlantic basin, us basically in the UK. So it's a really powerful model, and that changing the salinity by sea ice or the amount of runoff has a profound effect on the operation of this system and the transfer of heat between the hemispheres.